Welcome students. Problem set 3, lesson number 3, circle. In last lecture we have solved question number 2 to question number 5. Today we are going to solve the question number 6 to question number 10. And question number 6 is, in the figure, circle with center M touches the circle with center N at point T. There are two circles. This is a big circle with center M and this is a small circle with center N. These two circles touch at point T. Radius Rm touches the smaller circle at point S. Radius Rm of a big circle touch the smaller circle at point S. Radii of circles are 9 cm and 2.5 cm. So radius of big circle is 9 cm and that of smaller circle is 2.5 cm. Find the answers to the following questions. Hence find the ratio ms is to sr. Here is the one construction: join ns, nt and nm. So what is construction? Draw segment ns, segment nt, segment nm. Now nt is equal to ns, nt is equal to ns is equal to 2.5 cm. Radius of a small circle mt is equal to mr, mt is equal to mr is equal to 9 cm. Radius of big circle. Now number 1, we have to find the length of mt. So mt is equal to 9 cm and reason is radius of big circle. This is first answer. Number 2, find the length of mn. So we have to find mn. So mt is equal to mn plus nt. mt is equal to mn plus nt. Reason is m dash n dash t, m dash n dash t. Now we have to find mn. Mn is equal to mt minus nt. So value of mt is a 9 and nt is a 2.5 is equal to 6.5 cm. Therefore our second answer mn is equal to 6.5 cm. This is second answer. Now number 3, find the measure of angle NSM. So this angle MR is tangent to the smaller circle. MR is a tangent to the smaller circle and NS is a radius of a smaller circle. So according to the tangent theorem, angle between radius and tangent is a 90 degree. Therefore this angle NSM is equal to 90 degree. So we write for small circle MR is tangent NS is radius. Therefore angle NSM is equal to 90 degree. Reason is tangent theorem. Now number 4. Find the ratio MS is to SR. MS is to SR. At first we have to find MS. For this we have to consider triangle NSM. In this triangle, this angle is a 90 degree. Therefore this triangle is a right angled triangle. So we can apply Pythagoras theorem for this triangle. So for here this angle is a 90 degree. Therefore MN will be hypotenuse, and we have a value of MN as a 6.5 centimeter. NS is a radius of a smaller circle. It is 2.5 centimeter, and we can find SM or MS by applying Pythagoras theorem. So we write, in triangle NSM, angle NSM is equal to 90 degree. Therefore NM square, or we write MN square, MN square is equal to NS square plus MS square. We have to find MS. Therefore MS square is equal to MN square minus NS square. Therefore MS square is equal to MN. What is value of MN? 6.5 square minus NS is a radius, and its value is a 2.5 square. Now MS square is equal to 6.5 square minus 2.5 square. This is just like A square minus B square. We know expansion of A square minus B square is A minus B into A plus B. Therefore we write MS square is equal to A plus B, that is 6.5 plus 2.5 into 6.5 minus 2.5. Therefore MS square is equal to 6.5 plus 2.5, A square minus B square, A plus B into A minus B. 6.5 plus 2.5 is a 9, and into 6.5 minus 2.5 is a 4. 9 into 4 is a 36. Therefore we get MS square is equal to 36. Therefore MS is equal to square root of 36 is a 6 centimeter. Therefore we get MS is equal to 6 centimeter. Now we have to find SR. So here MR is equal to MS plus SR. MS plus SR, and that reason is M dash S dash R. MR is equal to MS plus SR. So we have to find SR. SR is equal to MR minus MS is equal to MR is a radius, it is 9 centimeter, and minus ms is a 6 is equal to 3. Therefore SR is equal to 3 centimeter. We get SR is equal to 3 centimeter. Now we have to find the ratio ms is to SR. That is ms upon SR is equal to ms is a 6 and SR is a 3. So is equal to 2 upon 1. Therefore ms is to SR is equal to 2 is to 1. ms is to SR is equal to 2 is to 1 is the last answer. Question number 7. In the figure, circles with centers x and y touch each other at point Z. There are two circles, circle with center y and circle with center x. These two circles touch with each other externally at point Z. A secant passing through Z intersect the circles at points A and B respectively. If we draw a secant passing through point Z, then it will intersect both the circles at point A and B respectively. Prove that radius XA parallel radius YB. Fill in the blanks and complete the proof. Here one activity is given to you and we have to complete this activity to prove XA radius XA parallel radius YB. Draw segments XZ. Construction. Draw segments XZ and YZ. So here we write YZ. Now by theorem of touching circles, x, y, z are dash dash. If two circles touch with each other externally, then their point of contact lies on the line joining their centers. That is, the point z lie on the lines joining the centers x and y. That is, the points x, z, y are collinear. Therefore, here we write collinear. Collinear. Now angle XZA. This angle XZA is equal to angle BZY. These two angles, opposite angles. Angle XZA congruent angle BZY. Opposite angles. Let angle XZA is equal to angle BZY is equal to A. Now segment XA congruent segment XZ. XA congruent XZ. Radii of the same circle. Reason is a radii of same circle. Therefore angle XAZ, this angle XAZ is equal to this angle XZA. Angle XZA is equal to A. Isosceles triangle theorem. In triangle XAZ, XZ is equal to XA. Radii of a same circle, therefore this triangle is isosceles triangle. So according to isosceles triangle theorem, the angles opposite to congruent sides are congruent. So angle opposite to XZ is this angle and angle opposite to XA, this angle are congruent. Let that angles are A. This is due to the isosceles triangle theorem. Similarly, segment YB congruent segment YZ. So we write here segment YZ and reason is radii of a same circle. Radii of same circle. Now angle BZY. This angle BZY is equal to this angle ZBY. So we write here angle ZBY is equal to A. Reason is isosceles triangle Isosceles triangle theorem. Isosceles triangle theorem. From equations 1, 2 and 3, angle XAZ congruent angle ZBY, angle ZBY, therefore radius XA parallel radius YB, alternate angles test. Alternate angles test. Question number 8. In the figure, circles with centers X and Y touch internally at point Z. There are two circles. This is a big circle with center Y, and this is smaller circle with center X, and these two circles touch each other internally at point Z. Segment BZ is a chord of bigger circle. Segment BZ is a chord of bigger circle and it intersects smaller circle at point A. Prove that segment AX parallel segment BY. Now let's solve this example. Now segment AX congruent segment XZ for the smaller circle, segment AX congruent segment XZ, radii of same circle, radii of same circle. Therefore, in triangle XAZ, AX is equal to XZ. These two sides are equal. Therefore, it is isosceles triangle. Therefore, this angle and this angle are congruent. Angle XAZ congruent angle XZA. XZA. Reason is isosceles triangle theorem. This is equation number 1. Now for this circle, big circle YB is equal to YZ. Segment YB congruent segment YZ. Reason is radii of same circle. Therefore, in triangle YBZ, in triangle YBZ, this side and this side are congruent. Therefore, it is also isosceles triangle. Therefore, this angle and this angle are congruent. So, angle YBZ, YBZ congruent angle YZB. YZB. Reason is isosceles triangle theorem. Therefore, angle YBZ congruent angle, this angle YZA, YZB, this angle YZB means angle XZA. Angle XZA. Reason is Y dash X dash Z y dash x dash z and b dash a dash z and b dash a dash z. But angle x z a is equal to angle x a z from equation 1. Therefore angle y b z congruent angle x a z from equation 1. So these two angles are congruent. Y b z. This angle y b z congruent angle x a z. Therefore segment AX parallel segment BY, these two angles are congruent. Therefore these two angles are corresponding angles. If AX parallel BY and BZ is a transversal, then these two angles are corresponding angles. Therefore according to corresponding angles test, segment AX parallel segment BY, reason is corresponding angles test. Question number 9. Line L touches the circle with center O at point P. This is a line L touches the circle at point P and O is the center of a circle. Q is midpoint of radius OP. Q is midpoint of radius OP. RS is a chord through point Q such that this chord RS parallel to line L. If RS is equal to 12, find the radius of a circle. So let's solve this example. RS is equal to 12. It is given. Then line L is tangent and segment OP is radius. Line L is a tangent and OP is a radius. We know that the angle between tangent and radius is 90 degrees. Therefore this OP is perpendicular to line L. Therefore segment OP perpendicular line L. This is due to tangent theorem. Now we have given RS parallel line L. RS parallel line L, it is given. Therefore segment OP perpendicular segment RS. OP is perpendicular to line L. Line L is parallel to RS. So OP is also perpendicular to RS. Therefore QS is equal to 1/2 into RS. So OP is a perpendicular drawn on the chord RS. So perpendicular drawn from the center of a circle on any chord bisects that chord. Therefore Q is a midpoint of RS. Therefore QS is equal to half of RS. Reason is perpendicular drawn from the center of a circle to any chord bisects that chord, that is result. Therefore QS is equal to 1 upon 2 into RS. RS is at 12. Therefore QS is equal to 6. So we get QS is equal to 6 here. This QS is equal to 6. Let radius of circle is equal to R. Now OQ is equal to half of OP. OQ is equal to half into OP. Reason is Q is a midpoint of OP. Q is midpoint of OP. Midpoint of OP. Therefore OQ is equal to half into R. This will be half into R. OS is equal to R. Reason is radius of circle. Now this is a R. Now in triangle OQS, this angle is 90 degree. Reason is OP perpendicular RS. So we write in triangle OQS, angle OQS is equal to 90 degree. Reason for this is segment OP perpendicular segment RS. So we can apply Pythagoras theorem for this triangle. This angle is 90 degree. Therefore side opposite to this angle, that is OS, is a hypotenuse. So we write OS square is equal to OQ square plus QS square. Reason is Pythagoras theorem. Therefore OS is R, square of R is R square is equal to OQ 1 upon 2 into R square plus QS is a 6 square. Therefore R square is equal to 1 upon 4 R square plus 36. Therefore R square minus 1 upon 4 R square is equal to 36. So 4 into R square, 4 R square minus R square upon 4 is equal to 36. 4 R square minus R square is 3 R square upon 4 is equal to 36. Therefore R square is equal to 36 into 4 upon 3. Therefore R square is equal to, divide this 3 by 36, it will be 12. Therefore R square is equal to 48. And this 48 will be 16 into 3. Therefore R is equal to, in root 16 into 3 is equal to 4 root 3. R is equal to 4 root 3. Therefore radius of circle is equal to, therefore radius is equal to 4 root 3. This is answer. Radius is equal to 4 root 3. Question number 10. In the figure, segment AB is diameter of a circle. Segment AB is diameter of a circle with center C. line PQ is a tangent. This line is a tangent which touches the circle at point T. Segment AP perpendicular line PQ and segment BQ perpendicular line PQ. Prove that segment CP perpendicular segment CQ. Here is a construction. Draw CT, segment CT, segment CP and segment CQ. Now let's see. This line PQ is a tangent to the circle and segment CT is a radius. Therefore this angle is a 90 degree. Therefore segment CT is perpendicular to line PQ. Therefore we write line PQ is a tangent and segment CT is radius. This is given. Therefore segment CT perpendicular line PQ. Reason is tangent theorem. Reason is a tangent theorem. Segment CT is perpendicular to line PQ. Now segment AP perpendicular line PQ and segment BQ perpendicular line PQ. Segment AP perpendicular line PQ and segment BQ perpendicular line PQ. It is also given. Therefore AP perpendicular PQ, CT perpendicular PQ and BQ perpendicular PQ. Therefore AP parallel CT parallel BQ. Therefore we write segment AP parallel segment CT parallel segment BQ. Reason is lines perpendicular to the same line are parallel to each other. Lines which are perpendicular to the same line, these three segments are perpendicular to the same line PQ. Therefore these three segments are parallel to each other. Lines perpendicular to the same line are parallel to each other. Therefore these three segments AP parallel CT parallel BQ and AB transversal. Therefore we write AC upon BC is equal to PT upon TQ. AC upon BC is equal to PT upon TQ. This is property of three parallel lines and their transversal. So we write here property of three parallel lines and their transversal. But AC is equal to BC. AC is equal to BC. Radii of a same circle. Radii of same circle. Therefore we put BC is equal to AC. AC upon AC is equal to PT upon TQ. Therefore, PT upon TQ is equal to 1. Therefore, PT is equal to TQ. Therefore, we write by squaring PT square is equal to TQ square. Squaring on both sides. This is equation number 1. Now consider triangle CTP. In triangle CTP, angle CTP is equal to 90 degree. Reason is a segment CT perpendicular line PQ. Therefore, we apply Pythagoras theorem for this triangle. This angle is a 90 degree. Therefore, CP is a hypotenuse. Therefore, CP square is equal to CT square plus PT square. Pythagoras theorem. Pythagoras theorem. From this, find CT square is equal to CP square minus PT square. This is equation number 2. Now consider triangle CTQ. In triangle CTQ, angle CTQ is equal to 90 degree. Reason is segment CT perpendicular line PQ. This is also right angled triangle. For this triangle, we can apply Pythagoras theorem. This angle is 90 degree. Therefore, side opposite to this angle is CQ. CQ is a hypotenuse. Therefore, CQ square is equal to CT square plus TQ square. Reason is Pythagoras theorem. This is equation number 3. Therefore, CQ square is equal to CT square. From equation 2, CT square is CP square minus PT square plus from equation 1, where is equation 1? TQ square is equal to PT square. So we write TQ square is equal to PT square. This is from equations 1 and 2. Now here PT square get cancelled. Therefore, CQ square is equal to CP square. Therefore, CQ is equal to CP. Taking a square root. Taking square root on both sides. Therefore, segment CP congruent segment CQ is proved.